Yeah, listen ma. This is one symmetric circuit diagram. Symmetric circuit diagram. And here we are taking the concept it as this is the center, right? So this is, see, this is the, if you consider like this one dotted line, with respect to this dotted line, this side is same and that side also same. And in this circuit, it seems to be a junction. So here, observe carefully, it seems to be a junction. This is a junction. It seems to be a junction, but that's not junction. What is the meaning of junction? Junction is nothing but where too many electronic components are gathered. That is called junction. That is called junction. So this is not junction actually. Why? Because like these symmetric circuits, it seems to be a junction. It is a virtual junction. Virtual junction. It means what? This can be considered as like this, without, like this. See, so now these two resistors, observe, and this resistor and this resistor, these two resistors are series. In the same way, this is R and this is R. All are identical resistors are arranged in the circuit. So now, and here this is R and this is also R. This is one type of model actually. Observe carefully. Previously, these two are intersected. These two are combined and forms a junction. But that's not a junction. It seems to be, it considered as a virtual junction. In case of virtual junction, without joint, just I observe, just I considered like this and like this. You're getting? Now, with this, here I am taking the concept as like this. Again, this can be treated as, see here. This is R and this is R and R. These two are series. If these two are series, effective series combination is R plus R, 2R. So now that is like this. 2R. And anyway, this is one resistor R. I am taking like this. I am taking like this R, and then this is R and this is also R. Again, these two are in series combination. R plus R. What's that mark? 2R. To R, right? So now again, this is R. This is R. I consider like this. I consider like this. Okay. Now observe carefully, ma. Here, observe carefully. The same circuit is present. The same circuit is present in the downward direction also. In the downward direction also. So here I am naming this one as this is A and this is B. With respect to AB, I need to calculate the effective resistance. This is A and this is B. This is B. Okay. Now here R and 2R. How these two are? Parallel, right? So the same consideration is for the downward part also. Upward part, whatever the symmetric concept is present, in downward part also same symmetric concept. It means how come we consider that? The same resistor, here this combination like this. Like this. So it means this is R. And this is again R. This is 2R and this is R. This is R. The same consideration can be followed for the upward part as well as the downward part also. Downward part also. Okay. So now based on this, here I am taking this R and 2R both are in parallel. So R1 R2 by R1 plus R2. So this combination became as only with the one resistor I am representing as like this. So for these two, I'm representing like R into 2R by R plus 2R. R1 R2 by R1 plus R2. That is 2R square by 3R. Then 1R get cancelled. Then what's the value? 2R by 3. This is 2R by 3. These two are representing it as 2R by 3. And now here R is present. And here also R is present. In between, what is that? 2R. And here they mentioned this is A and this is B. And again, whatever the consideration is taken in upward direction, in above case, the bottom also same thing. R and this is 2R by 3 and same this is R. These two are parallel. You will get 2R by 3. This side R, that side R. Now, here this R, 2R by 3 and R. These three are in series. R, 2R by 3 and R. These three are in series. Series means what is the value? R1 plus R2 plus R3. So now this part I am taking here as like this. Observe this part R plus 2R by 3 plus R plus R. R plus R what? 2R plus 2R by 3. That is LCM is 3. 3 2s are 6R plus 2R 8R by 3. This part of the circuit is 8R by 3. That I am mentioning as like this. See here. 8R by 3. Now, what is this? 2R. And what about this? Again, R plus 2R by 3 plus R. R plus 2R by 3 plus R. Same symmetric part. That is, what's the value? 8R by 3. Now these three are parallel. Why? Because they mentioned this part is A and this part is B. So with respect to that, these three are in parallel. So when you consider those three are in parallel, then what's the value of that? That value is 4R by 5. What's the value, ma? This value, same, R1, R2, R3 by, if you take the calculation as like this, if you take the calculation as, listen ma, here R equivalent is equal to R1, R2, R3 by R1, R2, R1, R2 plus R2, R3 plus R3, R1. If you consider this is R1, R2, R3, substitute those values, then you will get the value as 4R by 5. 4R by 5. Like that, we need to solve this problem. Okay, very simple. Observe carefully. Very simple, ma. At first, this diagram is like this. Once again, I'm repeating. This diagram is like this. It seems to be a junction, but this is not a junction. It's a virtual junction. So here I am replacing that like this. Without joint, I consider like this. And these two are in series combination. So R plus R, 2R. This is the part of that. This is the part of that 2R. Okay. And this is R. This is a part of that. This R and 2R both are in parallel. Now, this R and 2R can be in series with R, this side R and that side also R as well as R. This is the above part of that. Anyway, across A and B, we need to calculate the equivalent resistance. This R equivalent also taken as RAB also here. RAB also. So here we are considering that R plus R, these two are in series. That's why 2R. This is the part of that 2R. Okay. Now, whatever the above part is present, the bottom part, the below part also same. R, and this R plus R, 2R. R, 2R. I consider like this. And anyway, this is R. and this side also R, identical resistors. So R is this side here and R is this side here. Now the above part R and 2 are again in parallel combination. R1 R2 by R1 plus R2, R1 R2 by R1 plus R2. So 2R square by 3R, that is 2R by 3. So replace these two resistors with 2R by 3. Now anyway this side R is present, that side R is present. So the above part can be simplified like this. Are you getting ma? Now with that here R, anyway the bottom part what I said right now is R, and this is 2R by 3 and this is R, 2R by 3 and this is R. So 2R by 3, R and R, this is nothing but 8R by 3. Why? Because these three are in series combination. So R1 plus R2 plus R3, what's the value of that? 8R by 3. Replace these three resistors R, 2R by 3 and R. These three resistors replace with only one resistor, and that is 8R by 3. Getting? Now anyway this is 2R and this is again R, 2R by 3 R. Again these three are series combination as same as the above one. So that also 8R by 3. Now 8R by 3, 2R and 8R by 3. These three are in parallel combination. In parallel combination of resistors, we used to get it as R1, R2, R3 by R1, R2 plus R2, R3 plus R3, R1. Then that value became as 4R by 5. Getting ma? This is one circuit diagram. With respect to here, question is calculate the effective resistance between the points A and C. This is A and this is C. So whenever they said to calculate the effective resistance between A and C, A is the positive terminal, A is the positive terminal and C is the negative terminal. Like this. Calculate the effective resistance between A and C. A is the positive terminal I connected here and C is the negative terminal. With respect to this, I need to calculate in the form of symmetric. So I am taking, this is the reference line. Reference line. With respect to this reference line, this side part is symmetric to that side part. Left side part is symmetric to right side part. Okay, as same as the left side part, the right side part is consisting R by 2, R by 2, like that. Okay, now how we are representing that? Listen ma, this is R by 2 and this is R by 2, as same as I am representing here, like this, R by 2 and this is R by 2. This I am naming it as A and here this is naming as C. Okay, now so above this, observe carefully, above this R by 2, here one R is present, here another R is present. Anyway, this is a reference line. Symmetric is nothing but no current passes through BO. On this reference line, no current passes and this resistor is invalid. Okay, now R by 2, R and R. So here I am taking that R is like this and R is like this. R and this is R. Okay, so now these are taken like this. And again, here we are considering that this part R by 2 and here R and here also R by 2, R. So now here I am considering that R. It means these three parts seems to be parallel. These three parts seems to be parallel. These three resistors are parallel. These three resistors again parallel. So now thereby here, how come we consider that? With that, we are taken as, listen, this part I am considering that R equivalent, otherwise R dash, here I am taking R dash, R by 2. three resistors R1, R2, R3 by R1, R2, R2, R3 plus R3, R1. R1 is R, again R2 is R, R3 is nothing but R by 2 whole divided by R1, R2, R into R square plus R2, R3, R into R by 2, R square by 2 plus R3, R1, R by 2 into R square by 2. Now R dash is equal to R into R cube by 2 whole divided by LCM is 2. Here 2R square plus R square plus R square. 4R square by 2. 2 get cancelled. R square get cancelled. Only R remains, that is R by 4. If you calculate this part, that is R by 4. Now replace these three resistors R by 2. I am replacing with only one resistor. The value is R by 4. And again these three also same R by 4. This is A and this is C. A and this is C. R by 4, R by 4. 2 times repeated series combination. Then you will get that R equivalent, RAC is equal to NR. N is nothing but 2 resistors. R is nothing but R by 4 here. 2 1s are 2 2s are. And that is what's the value, ma? R by 2. R by 2 is the answer.